brief introduction about myself. I am Praveen Raghuvanshi, working at Harman International as a principal engineer. It's an audio company, so you might have seen these speakers, amplifiers. So our company manufacture and develop software for that. So today's session is about applying data science and machine learning using Microsoft.NET technologies. So before I start the session, I would like to acknowledge a few of the people. So for the data set, I will be using from crickseed.org, and the organizers for AzConf, sponsors, and least but not the least, these participants. So I have few questions. Please help me with the answers on that. So how many didn't like the lunch? Please raise your hand. Not a single one. That's good. Appreciate that. How many are not .NET developers here? Okay, good. So how many of you haven't tried their hands in data science and machine learning? Please raise your hand. Oh, it's a good amount. So you will be interested to know the things as part of the Microsoft.NET ecosystem. And how many of you haven't programmed in Python or R? Okay, good. And last but not least, how many of you have been trying their hands in data science and machine learning and struggling due to non-.NET ecosystem? Please raise your hand. Okay, so I have one people in the back. Good. Okay. So before I start the session, I just want to see the challenges that we get if we have an ecosystem where a lot of programming languages exist. And same can be considered as a case within our language ecosystem. So you need to identify the languages and let me know. So which language is this? Any idea? Any guesses? Okay. So this is the iris. Any idea on this? This is German. This one? Yes, this is Japanese. Do you know what it is? Okay, I'll let you know. Okay, no problem. This one? Hindi. Yeah, or Hindi you can say. So all these mean good morning. So in Japanese, it's called as Ohayo gozaimasu. That is what is written over here. So you see challenges with the language itself. If you know one language and moving to another language, it's little difficult for you to grasp the underlying concepts of those languages. And you may be struggling with the syntax and other things. So if you are from a .NET world, then in that case, learning Python or R, it becomes a challenge. You will be mostly dedicating your time in identifying the syntax for that language instead of learning the concepts. As data science and machine learning is being present in the other languages such as Python and R for a long time, but not in the .NET ecosystem. So you see there is a plethora of languages that are present, and it's predominantly dominated by two languages. One is Python, the other one is R for data science and machine learning. So today's session, I'll be focusing on two things. One is data science, which includes the exploratory data analysis, and the second one is the prediction, which is part of the machine learning. So before I jump into the demo and other things, just wanted to brief on these topics. So exploratory data analysis is mostly about analyzing the data and visualizing it to the presenter so that we can make meaningful decisions out of that one. So if you look at a raw Excel sheet, it becomes tedious for you to analyze the Excel sheet, data inside an Excel sheet or data in a database. You need a way to transform that data into a meaningful way and in a visualized way. So there comes the importance of exploratory data analysis. So here is the example of if you want to buy a house, you need to consider number of bedrooms, type of a house, which can be apartment or a villa, then a locality, and a crime rate. So these are the various factors that will be involved in getting the prediction for that kind of a problem statement. So this is very much required for an exploratory data analysis. And the way it is achieved through a data frame. So in Python also it's there, in R also it is there, data frame. The same concept has been provided in .NET as well now. So you can leverage the same concept that is present in Python or R as a data frame. Data frame is a basic unit. It's kind of a tabular data structure where you have rows and columns, and you can extract the information in that or transform the information into that data frame structure, and then on top of that you can perform multiple operations to get a visual representation of that one. So for example, this is a basic Excel sheet representation of a data set wherein you have two or three variables present. One is name, age, and destination. So this is a raw form that is present in an Excel sheet. The same gets transformed into a data frame like this on the right side. If you see, so you get the same thing but with different columns and rows inside that. Now that was a machine, that was a data science part or the exploratory data analysis. Now second part is how to make the predictions. So for making the predictions, you need to have understanding on the machine learning part of it. So I'm just briefly touch upon on the machine learning as well. So machine learning is getting computers to program themselves. If a programming is automation, then machine learning is automating the process of automation. So there are two factors involved in a normal traditional approach where you provide the data and you provide the input, and it gets fed into the computer and you get an output. Whereas in case of a machine learning, you are mainly focused with the data and you know the output. Then you provide and feed it into the computer. That gives you an algorithm, which is nothing but a program. So using that program, you can provide further data and make outcome of that one. So it's like, I want to add two numbers. So in that case, you will be writing A plus B. So A plus B, you know that. Okay, so in a traditional one, you will define what is A plus B. Whereas in a machine learning, you don't know, it has to be done, the sum has to be done through A plus B or something else. In that case, what you do, you know the input, okay, there are two numbers, 2 or 3, and there is an output called as 5. So you feed in those things, and the computer will automatically determine what should be the algorithm, such as A plus B. So that will be automatically generated out of that input and the output data. So it's more of like this. So you are feeding an input wherein you have a red fish, which has an eye, which has limbs, okay, which has a tail. You feed in another type of fish. You feed in third type of fish. And this is the input data, which is representing a fish. So you know that this is a fish, but computer doesn't know what it is. So based on the certain features of a fish, like it has an eye, it has tails, okay, it has fins. So all those will act as a features for that input data. And once the machine understands these features, they will identify and tell you, okay, what kind of an object it is. So in this case, it is a fish. So after once the model has been developed, you feed in the new type of a fish to it, and machine will tell, okay, it is a type of a fish. So there are some prerequisites for ML. So one is a pattern should exist, then the mathematical or model or algorithm is unknown. So in this case, we don't know what is A plus B, whether the algorithm is doing the sum using A plus B or something else. We don't know those things. And yeah, the third very important thing is in order to have a good model out of the machine learning, we need to have an abundance of data. This is a prerequisite, you can say. Now coming to the ML frameworks, so there are a lot of frameworks available in the machine learning ecosystem, like Cafe2, and some famous ones are like PyTorch, Then you have TensorFlow, Keras. So the people who are coming from the Python background, they prefer to leverage those frameworks like PyTorch or TensorFlow or Keras. Whereas for the .NET ecosystem, there are very limited ones. So one of them is ML.NET, which I'll be talking about. Now, why .NET needs a ML framework? Already we have frameworks for Python, like PyTorch, TensorFlow, and everything. Here is the reason. Like we have around 1.5 million .NET Core developers. Okay, and C# is the top within the top 5 languages, and it is the most loved one framework. And top 30 highest velocity open source projects are part of the .NET ecosystem. And it's faster than Node.js. It's like 7 times faster. And 40% new to .NET are students. So it's like it's a very evolving technology. It's been there for a long time, but the change that we have seen from Microsoft in the .NET ecosystem is tremendous. Like they moved from the desktop to the now cross-platform thing by introducing the .NET Core. Now coming to the adoption, like 5 million .NET developers are there. Then Visual Studio, 1 million downloads are happening. Then 600K new .NET Core users are getting added. So you see a big statistics for the .NET ecosystem. That is the reason Microsoft is investing in developing the ecosystem for IoT, machine learning, and data science and other things. So now coming to ML.NET. So this is a framework from Microsoft for developing custom AI or ML applications. It was originated in 2002 as part of Microsoft research project. So you can imagine how old is this ML.NET. It's not very new to the world. It has been there with Microsoft, but it was traditionally used within Microsoft. I think a couple of years back, they open sourced it for the public usage. And there are different things how you can create the applications using AI ML applications within the Microsoft ecosystem. So for example, you have Azure Cognitive Services, you have pre-trained models like Onyx, Core XML. So these are like where you don't have much control and you want a ready-made kind of a solutions. So for those purposes, you prefer to use these services, but they comes with a cost. There is nothing called as a free in these cases. Whereas if you want to build your own custom thing, you want to have more control. So if you see here, on the right side, you have harder or fast full control. On the left side, you have easier or less control. So it depends on your requirement and the problem that you are solving. That will help you decide what kind of framework to use. So if you want to have a more control, finer control, then better go with the ML.NET or Azure Machine Learning Studio. And the good part of ML.NET is like it's an open source, it's compatible with other frameworks as well. I'll let you know that also. And these are some of the benefits of using a ML.NET. Like you can build your own custom models by writing C# or F# code. So you need not to learn Python, R, or anything. If you are a .NET developer, you are good to use it and within your Visual Studio or Visual Studio Code directly. You don't need any Azure subscription, you don't need any internet or those things. It's very much a developer focused, means whatever you are trying to write, it will be on your machine. So you can play around, you can run it for a long, you can run it for a small duration. So it's very flexible in those things. Extensible in the sense you can develop models within using ML.NET, transform it into a common format, which we call it as a Onyx format. Okay, and that can be consumed within different frameworks such as TensorFlow, PyTorch, and others. So it's very much extensible. Or you can leverage their models in ML.NET also. So if you have a ready-made model that was developed in PyTorch or TensorFlow, but they have been exported to Onyx format, then you can leverage and consume that model inside your ML.NET application. So you need not to write your things from scratch. And the And one of the best benefit of that one, like Python and R has a good ecosystem, so a lot of models are already present. So you need not to go and write something from scratch. Then proven means it has been used internally in products like Office and Bing for years, and it's an open source cross-platform, runs on all the platforms. So it's like a proven at scale and enterprise ready. So when I say enterprise ready, currently is being used in Bing Ads for ad prediction, Excel for chart recommendation, PowerPoint for design idea. I think you might have seen a design ideas tab coming in new PowerPoint, which suggests you a template based on the content that you are using. So that is being driven by ML.NET. So a lot of things are being driven by ML.NET in the background. And now you have Visual Studio 2022, wherein code suggestions are being there. So that is also driven by ML.NET. So these all are running internally within that application only. So you don't need an internet for that. You don't need any kind of integration for that one. You just need to build it with your application and you are good to go. Then Windows Defender is there, then Azure Stream Analysis. So if you want to integrate with your Azure thing, you can easily integrate with it. And there are a lot of use cases for that. So the possibilities which you can achieve using ML.NET, yeah, it doesn't cover each and everything as we have for other frameworks, but as it is still evolving, and the Microsoft is been adding it continuously, all the new things to it. So, but some of them are like sentiment analysis, issue classification, image classification, object detection, forecasting, then predictive maintenance, recommendation, and customer segment. So I think it's a good amount of possibility that is present, and you can get started with these things if you are a .NET developer. And this is a basic workflow of working within ML.NET ecosystem. It's more or less similar to what we have in other frameworks as well. Like you load the data by preparing it, then you extract the features of that one. For in our example, it was like the age and the name and the other parameters. Now, once the data is being prepared, you train it. You train using different algorithms that are present in ML.NET ecosystem or different algorithm that is present. Once the training is done, then you evaluate the model, and evaluation is done. Then once you are confident, okay, my model is giving good results or it is giving good accuracy, in that case, you will go and predict the outcome of a new output or new input. So that comes under your model consumption. So this, preparing your data, build and train, you can do in the background anytime, and consumption can be done on a different set. It can be through a console application, a web app application, a IoT-based application. So model can be consumed anywhere once you generate a model after training it. And this is the data pipeline for that one. Like you can load different type of data. You can load a text data, binary data, then a file, load data from a file. If you have a IEnumerable or a collection within your application, you can just input that one. So then parquet. Then once the data is loaded, then you need to transform it. For example, you need to transform for different, to make it ready for training. And those transformations have, some of them, those transformations, like you want to convert it into text, then schema changes, missing values, so some missing values are there. So that is more of a data cleaning part of the data pipeline. Then you need to normalize, okay, then encoding you have to do. For example, you have a name or a place, then it can't be understood by a machine learning or algorithm. So you need to use different kind of encoding to convert it into binaries. So that there the encoding will come into picture. Then you need to have a feature selection. You want to have like around 20 parameters are there, 20 features. Out of that, only 6 are of important to solving their problem. So in that case, you will just use 6 parameters or 6 features, and you will strip down the other features out of that. Then training is like identifying and using a proper algorithm. So there are different algorithms for different kind of problem statements. If you are using a regression or classification or object detection, So those all will have a different set of algorithms, and each one you need to see based on your problem statement. But some of them like boosted tree, then k-means, then support vector machines, then average perception. So once the training is done, you just evaluate. So evaluation is like running on a test data set and getting a result of the predicted thing. So once you are confident, okay, my model is good to be consumed, then we deploy it into different places. So which can be like Azure functions, ASP.NET, Core console application. So there are different ways you can consume it in any of the .NET application. It's not limited to one type or the other type. For today's session, I'll be utilizing a cricket data set for performing the exploratory data analysis and predictions. So some stats for the cricket, it's like it was from 2019 to 2022. So it's being played by 104 nations, and the valuation that is around like $6.7 billion. And there are around like 370 million viewers. So if you look at these numbers, you can imagine the importance of data that gets generated and utilized by different data scientists, machine learning, and AI practitioners to get the predictions out of that one, or to get insights of the data of a cricket. And the tools and framework that I'll be using today is the C# as a language, ML.NET as a framework for making the predictions or the machine learning part, then Jupyter Notebook. So like we have a Jupyter Notebook for Python and R, the same support will be there for C# now. You can easily go and use that one. Then this is a Azure Web App and Azure Functions if you want to deploy it to as a web app application. Then Danny is a Dataframe library. This is something I discovered while working on this one. Already the Dataframe library is present in the .NET ecosystem, but it has some restrictions which I'll let you know. That is the reason I have to go with this Danny as a library. And .NET Interactive is the one that provides you a .NET kernel within your Jupyter ecosystem. So you have, when you install Jupyter on your system, it by default comes with a Python or R interpreters, but it doesn't have the .NET inside. There's no support for C#, F#, and other languages. So for that, you need to install the .NET Interactive. So the problem statement for today is like performing analysis on cricket data set and predicting score on a specific ball within 6 overs. And the reason I took only 6 overs in a match of 20 overs, the reason I wanted to keep the problem statement very small for a demonstration purpose, but if you are going with a real-time problem, you need to have a big data set and you need to have a good computations for that one, good computing machine. And this is the data set, okay? So and it was taken for T20 match for men's. So duration was like from 2017 to 2021. Matches were like 1010. Teams were 56. And there are 22 columns with 231K records. And it's a mix of number and string. So if you look on the right side, you have 22 columns of features present in this data set. Now, what I'll be doing a data cleaning in this one. So I want to filter out the data set to include records till 6 over. I want to escape anything beyond 6 over. So that can be performed using the Dataframe APIs. And the reason I chose because of the low memory and fast execution for the demonstration purpose only. Then I'll check for null values. Then I'll aggregate. So for example, I have some of the data present, but it doesn't make any meaning out of that. We can't make any meaning out of that one. So in order to make the meaning out of that one, I need to create some more columns into that one that will be more meaningful for this problem statement. For example, there is a column for getting the run per ball, okay? The run wide is there, then any extras are there, but there is no column for getting a score per ball. So I'll be creating an aggregation on that one by utilizing runs off bat and extras. Same way, I'll be doing a cumulative sum, which will give me total score per ball. That means at that specific ball of a over, suppose like 2.1. Then I'll remove the features or column. So I'll be focusing only on these 6 or 7 features, and I'll strip off other things out of those 22 features. And the prediction will be like using these features only. Then for that, I'll be using the ML.NET. The analysis is done using Dataframe, my .NET Dataframe, and prediction is done using ML.NET. For that, I need to define the classes like match, match score prediction. A match will have these many features or the properties within that one. I'll load the data set, split a data set. This is a typical machine learning pipeline where you load a data set, you split a data set. So I'll be splitting it into train and test. Then I'll be using one hot encoding. For example, you have betting team, that's a string. So it has to be converted into numerics. So for that one hot encoding I'll be using. Then algorithm I'll be using is fast tree, because this allows you to divide the problem into 2 halves and make the execution faster. And this is in the last I'll be training, evaluating and predicting the model. So this is just the outcome of those things. I just put it in the as a reference. So this is a R squared score of 0.82 and RMSC is like 6.73, which is quite good. And this is on the different input that I have given on to the model, and the prediction given is like predicted score is 24, whereas actual score was 20, which is a good result, I would say. Good prediction, it's very much close. There is not much deviation. Then there is something called as auto ML, wherein it allows you to perform everything on its own. You just provide the input data or the data from the Excel sheet, and it does select the features, it does select the algorithm on its own. So you need not to do anything. It trains and gives you a model out of that one. So for example, it has trained onto 3 different, using 3 different algorithms, and these are the different statistics or the results came out of that one. So you can use any of those. And this is a web app that I developed, not a good UI, but wherein we have the input features and we are trying to predict a score. Okay, with that I'll move on to the demo part. Yeah. So this is a Visual Studio code, okay? And the good part is like you can write your content and execute the code in the same place. It's not like Visual Studio where you can just run the code. So this is all I have explained. So this is like a .about, which will tell you what version of the .NET Interactive is installed on your machine. This is just to verify if .NET Interactive is present or not. And this is how you define the NuGet packages, like what all packages you want to install for your application. So for example, you have like Microsoft.ml, then data frame is present inside the data analysis. And this is from the data Denny. And CSV helper is for manipulating the CSV. So if you do this, and the way it runs is like a normal notebook. So it has installed all these packages. And this is how you define the packages inside your Visual Studio, the same way I'm doing here. I have defined some constants over here, which is used within the application. Then the data set that I had for this ClickSheet, it is a zip file. So I need to extract that zip file, and I need to create a proper data set from that. And inside the zip file, there are multiple files for each year. So in order to, before giving it to the ML model, I want to make a single file so that all transformation is done as part of this method. So I forgot to execute this cell. That's why it was complaining. So for loading the data set, so before that I'll clear the previous data set if it is present in my local directory. This is the method for loading the data set, and this is the place I'm extracting that file, zip file, to a directory. Okay, looks like there is some error here. Anyway, let me get going. So this is the place I'll be loading a data set, and the way it comes is, I need to move on to this. So this is the article that I have written, which includes each and everything. It's more or less the same thing that was representing. So you define the constants, you have multiple CSV files. So this is how the files will be there from the Quicksheet dataset. So you can't use this one, so you have to merge all these files and exclude some of the files like info.csv. So for that you have this function. Then loading a dataset. Before that I will be clearing up the old things. And this is, so yeah, this is how the data set will look like once you load the data set from a file. Yeah, so this is the API actually. Microsoft.data.analysis.dataframe.load.csv. So this takes CSV as an input parameter, and it allows you to load that one. So this is how the data set looks like. So you have different parameters, like I said, there are 22 features in this. And then there are some APIs. I want to filter it for 6 overs only. I don't want to include anything more than 6 overs. So the over threshold is defined as 6.0. So anything beyond that one will be excluded. Then this is how we do it in Python. We want to get the top 5 count of a data set. This is how it will look like, and it will give you the information about top 5 records. Then if you want to see what is the data type for that one, then this is how you get that one using the info API. So there are, we can see around like 95,264 records present in our data set for 6 over. Then there is an API called as a description, which will give you the value. So for example, we have discarded anything beyond 6 over. You can see the maximum is 5.9 now, and the minimum is 0.1. So this concludes that the filtering is working, the filter API. Now, I told you that there are something that is not present as part of the raw data set that we got from the Quicksheet. For example, we don't have any column for score and total score. So for that, there is a transformation that we have to do on the raw data set. And this is how you do. You add a new column, which is like primitive data frame column. And it allows you to create a new column, and you can perform a transformation also. So for example, I am adding the content of that column runs off bat plus extras. So these two will be added, and once you do that one, 6 over data frame, you will see we have added a new column called as score because of that transformation. And if you see the content of that one, you will see the values in there. Like first ball, the 0 runs were there, second ball 0, third ball 1 run came, fourth ball 2 run came, and next ball only no run came. Now with this information, I want to add a column for total score also per ball. So for that, I am using I've created a utility method that allows you to add those things in your data frame. And once it is done, you can see there are two new columns now, score and total score. Whereas score is scored something on a ball, whereas total score is total score till that ball. So you can see it's getting added cumulatively. So that is how we can aggregate and perform transformation on a data set before feeding it to our ML model. Now feature selections, I told like there were 22 or 24 columns, but we are not considering all of them for this problem statement. We are just considering these many. So in order to filter out those things, this is the remove API. You can remove all the columns which are of not importance. So now we have only new 9 columns. Now coming to the training and prediction, so for that I'll be using ML.NET framework. So as I told, there is a limitation with the current data frame or the ML.NET, like you can't you can't save a CSV inside that. So in order to achieve that one, there is another framework called as Danny, which allows you to save a transformed data frame into a CSV. So I'll skip this step. Yeah, so see Danny.dataframe.toCSV. This is the API that allows you to save the data frame into a CSV. It is not present in the Microsoft data frame. So we have to leverage this one. Now this CSV can be used for making the prediction. So for making the prediction, I told you that we need to map the features into a class. Okay, so for example, you have venue, inning, ball. So these all are the features that are of importance to for creating a model out of that. So you need to map it. Then this is just for display purpose. Then score, the prediction score will be like total score will be there. That will be predicted by the algorithm. Now this is of importance. Okay, so what we need to follow is we need to first create a ML context. Okay, then load from text file. So here I'm specifying the CSV file, which is a transformed CSV file. And has header true means that file has a header also. And the separator character is comma here. And this is for splitting the data set. You can split the data set based on your convention. You can make it 80-20, 70-30. I'm using 80-20. That's why I'm specifying it as 0.2 over here. Now, with the ML context, yeah, I told that some of the columns are not in a numeric format, so we need to perform one hot encoding on them. So this is how you do one hot encoding. You will just use the API one hot encoding and provide the name of that column. And these are the features that will be utilized. So this is the encoded one and this is the normal one. Now for transformation, we can concatenate these things and append it to our model ML context. So once it is done, we are good with the, so this is the fast tree algorithm I have chosen. You can choose anything out of that one. Okay, you need to specify what algorithm you have to use for that kind of a state problem. And this is for training purpose. So fit is nothing but you want to train something, you just use the pipeline.fit. It will train your model on the data set that you have provided. Once the training is done, you can just evaluate. Okay, so evaluation is done on the test data set. Here you are specifying the test data set for that one. So once the evaluation is done, you feel, okay, the things are good, the model is good, you can save it. So this is the save API for that one. You can easily save it and it will generate a zip file which will include your model as well. Now once you have saved, you want to utilize within your application. It can be console, it can be web app or anything. The way to use it is, first you need to create a prediction engine. Okay. So there is an API called as a load. So once you specify that it will load the your model file, the ML context only. So there also in the consumer side, you have to create the ML context, load the file, specifying the file path, the zip file, and once that is done, you need to create a prediction engine which allows you to make a prediction. So here also you need to specify the same attributes for the input. For example, we had the features which we want to, based on which we want to predict. So for example, I want to make a prediction on 3rd over 4th ball, and batting team, bowling team, bowler, innings, these are the different attributes that is present. Once it is done, we provide it as an input to the predict method. So this is on the consumer side, on your web app or a console application. It will give you a prediction. So it will give you a score. Based on that, you can say, okay, your model has predicted good or bad. For example, you have 24 is the result, and the actual was 20. So this is how the ML.NET works. And the last thing I want to show is the same thing for a sentiment analysis using ML.NET Builder. So this is a plain sample application. Okay. So you see here, there is something called the machine learning model. You select that, add it. Yeah. So this is a different thing that you can perform using this. And the last, so you can run it on a local CPU, or you want to use GPU also, you can use file. So if I specify this file, this is a file which contains the data set. It will give you a preview also. So suppose I want to predict the column 1. Column 1 has a value of whether it is a good sentiment or a bad sentiment. For example, 1, this is a good one, this is a bad one, 0 is bad. So it will give you a preview. Just for 10 seconds I'll run. So it is utilized, trying to run on different using different algorithms, and this is the output it got. Yeah, so it has done. Now I'm giving my own input for making a prediction. So it will predict. So it has predicted 1, that means it's a good one, and 1% is like a bad one. And the last thing is it can generate a code for you in C#. And you can see how you can deploy. So this one concludes my demo. Yeah. And these are some custom stories. If you want to look into this one, it will be available on the slide. And this is a preview of AutoML. These are some references. Then resources are available here. Thank you.